If we're given the mass percent data for an unknown compound, we can determine the empirical formula. If we assume we have 100 grams of the unknown compound, we can easily convert our percentages into mass. Our compound is composed of 29% sodium, and so therefore we have 29 grams of sodium in our 100 grams sample. 40.5% sulfur means that we have 40.5 grams of sulfur in our 100 gram unknown compound, and 30.4% oxygen means that we have 30.4 grams of oxygen in our unknown compound. Now we will convert our grams into moles using molar masses from the periodic table. Sodium molar mass is 22.99 grams per mole. Sulfur has a molar mass of 32.06 grams per mole, and oxygen has a molar mass of 16 grams per mole. After doing the math, we end up with 1.26 moles of sodium, 1.26 moles of sulfur, and 1.90 moles of oxygen. To get the empirical formula, we'll divide our moles by the smallest number of moles. If we look at our moles of each element, we see that 1.26 moles is the smallest. So we're going to divide each of the moles by 1.26. We will end up with 1 sodium, 1 sulfur, and 1.5 oxygen. Since we know that empirical formulas must contain the smallest whole number ratio of elements, our 1.5 is a problem. So what can we multiply by so that our 1.5 turns into a whole number? Well, if we multiply everything by 2, that keeps the ratio the same and gets rid of our 1.5. So we would end up with 2Na, 2S, and 3O. Now that we have whole numbers, we can write our empirical formula. Na2, S2, O3.